Number 11. A big olive of mass m equal to 0.5 kilogram lies at the origin of an xy coordinate system, and a big Brazil nut of mass m, which is equal to 1.5 kilogram, lies at the point 1,2 meter. At time t equal to 0, a force Fo, which is equal to 2 I cap plus 3 j cap Newton, begins to act on the olive, and a force Fn, which is equal to minus 3 I cap minus 2 j cap Newton, begin to act on the nut. In unit vector notation, what is the displacement of the center of mass of the olive nut system at a time t equal to 4 seconds with respect to its position at a t equal to 0 second? In this question, we have to find the displacement of the center of mass of the olive nut system. So for this, they gave many information. First of all, they gave the value of the mass of the two material, which is olive mass as well as the Brazil nut mass, and also the location of the olive and also the location of the Brazil nut, and the force acting on the olive and the force acting on the Brazil nut is given here. Let's write the given first. So here I can write the information about the olive, and here I'm going to write the information about Brazil nut. Clear? So the mass of the olive, small m, which is equal to 0.5 kilogram, and the Brazil nut mass caps m, which is equal to 1.5 kilogram. The location of the olive, which is at the origin, so we have to write its location in terms of unit vector notation, which is 0 I cap plus 0 j cap, and it is unit is meter. Why? Because the origin, it is the olive is located at origin of xy coordinate system. Likewise, the location of the Brazil nut is given here as 1,2 meter. So we have to write 1 I cap plus 2 j cap, and its unit is meter. The force acting on olive is given here as Fo, which is equal to 2 I cap plus 3 j cap Newton, and then the force acting on the Brazil nut Fn, which is equal to minus 3 I cap minus 2 j cap, and its unit is Newton. Clear? So now for finding the displacement of the center of mass of the olive nut system, first I am going to find the acceleration of the olive and the acceleration of the Brazil nut. So now what I am going to do, I have to find the acceleration of the olive. Acceleration of olive, I am going to write here. We know the rule, the acceleration of the olive, which is A of O. So here O stands for olive. So the acceleration of the olive is given by the rule, the force acting on the olive divided by the mass of the olive. Likewise, I have to find the acceleration of the Brazil nut. The acceleration of the Brazil nut, A of n vector, which is equal to the force acting on the nut divided by the mass of the Brazil nut. Let's we apply the value of the force here. So the force Fo, which is nothing but 2 I cap plus 3 j cap. So I can write here as 2 I cap plus 3 j cap Newton divided by 0.5. So 2 divided by 0.5, so we can split into 2. When you split into 2, you will get the I cap and j cap separately, which is 2 divided by 0.5, which is nothing but 4 I cap. Likewise, 3 divided by 0.5, which is nothing but 6 j cap, and its unit right now, the unit of the acceleration, which is nothing but meter per second square. So we find the answer for the acceleration of the olive. Likewise, I have to find the acceleration of the Brazil nut. The force acting on the Brazil nut here is minus 3 I cap minus 2 j cap, its unit is Newton, divided by the mass of the Brazil nut is 1.5. Likewise, what I have to do, I have to split this into 2. So minus 3 divided by 1.5. Clear? Minus 3 divided by 1.5, which is nothing but minus 2 I cap. Likewise, minus 2 divided by 1.5, which is 1.33 j cap. So minus 1.33 j cap, and unit is meter per second square, which is nothing but the acceleration of the Brazil nut. So now what I am going to do, we have to find what is the displacement of the olive. Likewise, I have to find the answer for the displacement of the Brazil nut. So let's write displacement of olive at time t equal to 0 and time t equal to 4 seconds. Likewise, I have to find the displacement of Brazil nut for the same time interval t equal to 0 second to t equal to 4 seconds. Clear? So let's find the displacement of the olive first. So for that, we can choose the second equation of the equation of motion with constant acceleration. So we can write the displacement of the olive, that means delta RO, which is given, which is equal to initial speed multiplied by t plus half at square. Now you can see initially the olive is at rest in the origin, so initial speed is 0 and time t equal to 0, right? So this term will be 0, and for the when you substitute t equal to 0, the entire term becomes 0, right? When you substitute t equal to 4 seconds, this term will be 0. Why? Because the initial speed is 0. So when you substitute t equal to 0, better I can write here, at the time t equal to 0, you will get delta RO, which is equal to 0. But at time t equal to 4 seconds, what you will get, delta RO, which is equal to, you will get only half at square. Why? Because t value 4 seconds, but what is the initial speed? It's 0, right? So the first term will not become. So now what I'm going to do, this a here is nothing but the acceleration of the olive. So acceleration of the olive we already found out here as 4 I cap plus 6 j cap. So I have to use this number here. So if you substitute the acceleration of olive here, you will get delta RO, which is equal to half multiplied by, what is your acceleration here? 4 I cap plus 6 j cap. So I can write here 4 I cap plus 6 j cap, and the time for 4 seconds, right? So that means 4 square. So here, when you just simplify this, because we have to multiply this 4 square with 4, because 4 square is 16, 16 multiplied by 4, and then you have to divide by 2. When you simplify this part, you will get 32 I cap plus 48 j cap, and its unit here is meter, because we find the displacement, right? That means this value is nothing but the x value of olive, because the x naught and y naught, because it's a location, the displacement a location, which is x naught comma y naught. So the x naught value is 32, y naught value is 48. Likewise, we have to do the same calculation for the Brazil nut. So again, I have to use the same rule, which is delta R n, which is equal to v naught, so sorry, multiplied by t plus half the acceleration of the nut multiplied by t square. Again, when you substitute t equal to 0, it will be 0. So when you substitute t equal to 4, your delta R, which is equal to half multiplied by acceleration value. What is your acceleration value? Minus 2 I cap minus 1.33 j cap. So I have to write minus 2 I cap minus 1.33 j cap multiplied by 4 square. When you simplify this part, you will get minus 16 I cap minus 10.64 j cap, and its unit is in meter. That means this value is xn value, comma, yn value. Clear? This is the olive location. This is the Brazil nut displacement location. Now, by using this value, we have to find the center of mass of the olive nut system. So, in theory, the center of mass formula, x center of mass, which is given by the rule, the mass of the olive multiplied by x of olive. That means the x naught of olive. This is the value, right? Plus the mass of the Brazil nut multiplied by the x of n. That means the Brazil nut location divided by the cap sum, which is nothing but the mass of the olive plus the mass of the nut. Clear? Likewise, we have to write the same rule for y center of mass. So y center of mass, which is equal to m naught multiplied by y naught plus mn multiplied by yn. So don't get confused about O and N. O stands for olive and N stands for the nut. Clear? Divided by olive mass plus nut mass. Now we have to substitute the value here. If you substitute, what we'll get? The mass of the olive is 0.5 kilogram multiplied with x naught value here is 32 plus the mass of the Brazil nut is 1.5 kilogram and your xn value. What is your xn value? We have come back here. What is your xn value? Minus 16. Minus 16 divided by the mass of the olive is 0.5 plus the mass of the Brazil nut is 1.5. When you simplify this, we will get the center of mass of this olive is, which is minus 4 meter. Clear? Likewise, we have to substitute the value for y center of mass. If you substitute, you will get the mass of the olive here is 0.5 multiplied by y naught. What is the value of y naught? We have to see the value. Your y naught value is 48 here. So 0.5 multiplied by 48 plus 1.5 is the mass of the Brazil nut multiplied by yn. So what is our yn? Minus 10.64 minus 10.64 divided by 0.5 plus 1.5. Now we got the center of mass of the system as 4.02 meter. So this is the y center of mass. Clear? Now we have to give this center of mass system in terms of unit vector notation. So we have to write x center of mass, comma, y center of mass, which is equal to your x center of mass is minus 4 meter I cap. Clear? And y center of mass is 4.02 plus 4.02 j cap meter. Clear? So this is the answer for this question. X center of mass is minus 4, its unit is meter I cap, and y center of mass is 4.02 meter j cap. So this is the answer for this question. That's it. Thank you.